Good morning, everybody. Happy Thursday, which I'm sure feels like Friday for you guys. Today, we're going to be doing just a few examples in terms of composite area. So, composite area is where we're either taking areas and putting them together or taking two areas and subtracting them to find an unknown amount. So, this is going to be in lesson 20 in your book, and I've already copied down the three examples that I want to talk about today, starting with this first example here. So find the composite area of the shaded region. So what that means, we're finding the area of the shaded part right here. What we should automatically realize is that these are two circles. There's a big circle on the outside, and then if you try to envision it as this circle on the inside got cut out of the middle, so it's making that ring shape there. So we're trying to find the area of that shaded region. So I'm going to reference this picture first, and I did copy it down as well, but my picture is not as good as this one, obviously. But what we'll see is that the radius of this smaller circle is 2 units, while the radius of the larger circle from the center to the outside is 3 units. And so if I'm showing you on here, we've got 2 units as our radius for our small circle, counting 2 squares, and we've got 3 units for our radius of the larger circle. Now remember, to find the area of a circle, our formula is pi r squared, or pi times the radius squared. So what we're going to need to do is find the area of both these circles. Once we have the area of both these circles, what are we going to have to do with the area of the smaller circle? Yeah, we're going to have to take the area of the large circle, I'm just going to call it L, and subtract the area of the small circle. Once we do that, we'll have the area of the shaded region. So we'll start with the large circle. The large circle has a radius of 3, so our area is going to be pi times 3 squared. Remember, 3 squared means 3 times 3, so our area is going to be 9 pi. Now we could use 3.14 for pi as well. If we go back to the problem, let's see if it says one way or another, use 3.14 for pi, so we will do that. So I'm going to take my calculator out just to calculate that. 9 times 3.14, and we'll write that as well, 9 times 3.14, and that's going to give us an area of 28 and 26 hundredths. Now that's the area of the shaded circle. What we need to do now is cut out that center circle, which has a radius of 2. So we're going to do the same thing for that circle there. We're going to do pi times 2 squared this time instead of 3 squared. Well, 2 squared is 4, so that'll give us 4 pi. And if we do 4 times 3.14, once again, times 3.14, we get an area of 12.56. So what we need to do is subtract the areas of those two circles. When we subtract 28 and 26 hundredths minus 12 and 56 hundredths, we get 15 and 7/10 units squared. So the area of the shaded region is 15 and 7/10 units squared. So that's one composite area problem where we're subtracting the unshaded piece from the shaded piece to get to our solution. Let's look at a problem where we're doing something a little bit different than that. The next one that we're going to be looking at is exercise 2 in our book, which is the composition of a triangle and a semicircle. So I took the time to draw that beforehand as well. So we have a triangle and a semicircle. And believe it or not, we actually already have all the measurements that we need in order to find the area of both of these things put together. First of all, if this length right here is 4, it means that the radius of this semicircle is 4. So let's start by finding the area of the semicircle. We know from the last problem that to find the area of a full circle, we use pi r squared. This time we're going to do pi r squared divided by 2 because we're talking about half of a semicircle. So remember, our radius is 4. We're going to use our equation here. Pi times 4 squared divided by 2. And if we keep writing this out, pi is 3.14 times 4 squared, which is 16, all divided by 2. When we simplify this down and we do 16 times 3.14 divided by 2, we're going to get an area of that semicircle of 25 and 12 hundredths. And we're talking about centimeters, so we'll say centimeters squared. Now, we still have to find the area of a triangle. Well, we know the formula for the area of a triangle. Area is equal to base times height divided by 2, because it's half of a rectangle. We already know the base is 14. If we're looking at the semicircle, what does this line represent? So on the triangle, that represents the height of the triangle, but on the semicircle itself, it represents the diameter. And so we know that the diameter is equal to twice the radius, and that tells us that this height is going to be 8, because 4 times 2 is 8. So now we're going to use our equation over here. We've got our area is equal to base, which is 14, times height, which is 8, divided by 2. So when we, and like I said, I'm just using a calculator. I'm fine with you guys using that too. When we do 14 times 8 divided by 2, we get to an area of 56. And that's also centimeters squared. Well, if we're trying to find the area of all of this, what are we going to do with our area of the triangle and area of the semicircle? We're going to add those two values together. So we've got the area of the semicircle, 25 and 12 hundredths, and we've got the area of the triangle, which is 56. Make sure that you align your place values when you're adding there. And when we add, we get 81 and 12 hundredths centimeters squared. So there's one more problem that I wanted to talk about today, and it is this problem a little bit further in your book, example 3. So with a problem like this, we're still trying to find the area of the shaded region. It says redraw the figure separating the triangles, then label the lengths, discussing the calculations. Well, I redrew the shape. I'm not actually going to separate the triangles, but what I am going to do is I'm going to label the unknown sides, the ones that aren't labeled right now. We know this is a square, so we know that this length is 20. If this length is 20, it also means that this length is 20. But the diagram shows us that from here to here is 8 centimeters. So what should the length from here to here be? Well, we know the full length is 20. If we take 20 and subtract 8, we're going to get a length of 12 centimeters here. Then we're going to use the same process over here. We know that the length is 20. This time, we know from here to here is 6. So what is the length for the rest of that? Hopefully you're saying that length is 14 centimeters. Now we have enough information to find the area of all of these right triangles, because all 3 of these are 90-degree angles, and so we have a base and we have a height. And like we said in the last problem, to find the area of a triangle, we multiply base times height and then divide by 2. So I'm going to label these as triangle 1, triangle 2, and triangle 3. What we're trying to find is triangle 4. So we'll start with triangle 1. Triangle 1, our base is 12, our height is 20. 12 times 20 divided by 2. That's going to give us an area of 120. Triangle 2. Our base is 20. Our height is 14. 20 times 14 divided by 2. That's going to give us 140. Triangle 3. What's our base and height for triangle 3? We've got 8 and 6, and we're dividing that by 2 as well. 8 times 6 is 48, divided by 2 gives us 24. Now that we have the areas of all 3 of these triangles, we still have to find the area of 4. We don't know what the height is. We don't know what the base is. Is there anything else in this diagram that we can find the area of? Hopefully at this point you realize that we do have a square here, and we know how to find the area of the entire square. It's just going to be length times width, which is 20. So 20 times 20, this is for the square, is 400. Now, if we have the area of the square and then we remove triangle 1 and remove triangle 2 and remove triangle 3, we're left with triangle 4. How do you remove something in math? Kind of like in example 1, when we removed the center of this circle by subtracting, we're going to do the same thing here. Subtract triangle 1, 2, and 3 from 400. So we're going to do 400 minus triangle 1, which is 120, triangle 2, which is 140, and triangle 3, which is 24. And when we subtract all of that, 400 minus 120, 140, and 24, we get a grand total of 116. If we're talking about area, and we know that we're talking about centimeters here, what should be the label on this 116? Our area should be 116 square centimeters, or centimeters squared. So if you have any questions on problems like this, please let me know. This is either adding areas together or adding areas and then subtracting them from a big picture to find your total amount. Try out a few other examples in here. I'm going to list a few in Google Classroom so that you can have a couple to try. Specifically, exercise 3 here should be a good one to practice. But if you have any questions, like I said, please make sure that you're asking me, and enjoy the rest of your day, guys.